At 11:22 hours on March 18, 1945, 37 Messerschmitt Me-262s, swept-wing jet fighters capable of 870 kilometers per hour, screamed into a formation of 1,221 Allied bombers over Germany. In 11 minutes of slashing attacks, the German jets downed 12 four-engine bombers, while P-51 Mustang escorts, limited to 700 kilometers per hour, could only watch their charges fall from the sky in flames. The Junkers Jumo 004B turbojets powering each Me-262 delivered 8.8 kilonewtons of thrust per engine, propelling the 6,400-kilogram aircraft 170 kilometers per hour faster than any Allied piston fighter could chase. Fritz Wendel, Messerschmitt's chief test pilot, had described the sensation of flying the jet as feeling as if an angel were pushing. That angel arrived too late to change anything. The technological miracle devastating Allied bomber formations in March 1945 had begun 7 years earlier when Voldemar Voigt's design team proposed Project P-1065 to the Luftwaffe Air Ministry in summer 1938. By April 1939, Willy Messerschmitt received official commission to develop the Me-262, powered by two Junkers Jumo 004 engines. The first prototype, Me-262V1, lifted off from Augsburg on April 18, 1941, but with a single 700-horsepower Junkers Jumo 210G piston engine driving a propeller, not jets. The BMW P-3302 turbojet intended for the aircraft had failed bench tests in late 1940, producing only 570 pounds of thrust instead of the specified 1,300 pounds. Not until July 18, 1942, when Fritz Wendel piloted the Me-262 V3 prototype on a 20-minute flight from Lechfeld with two Jumo 004 turbojets installed, did the jet truly fly. If you're interested in how wars are actually decided by logistics, math, weapons, and doctrine, subscribe now, turn on notifications, and stay tuned for more in-depth World War II analysis. Let's continue. General Adolf Galland first flew an Me-262 prototype at Lechfeld on May 22, 1943. By November 2, 1943, Hermann Göring was asking about bomb pylons during a visit to the Augsburg plant. Hitler's May 27, 1944 order classified the Me-262 strictly as a fighter bomber, forcing the first production aircraft into the Sturmvogel bomber variant role. The Luftwaffe accepted 16 pre-production Me-262 A-0 airframes at Lechfeld between April 18 and 29, 1944, once engines finally became available. Erprobungskommando 262 formed under Captain Werner Tierfelder at month's end to evaluate the Me-262 A-1A Schwalbe interceptor. By March 1945, the jets were operational, flying against an enemy already crossing the Rhine. In workshops across wartime Germany, engineers at Junkers confronted an impossible equation. The axial flow turbojet required turbine blades capable of withstanding gas temperatures exceeding 680 degrees Celsius, while rotating at redline speeds approaching 8,900 revolutions per minute. Each Jumo 004 power plant weighed approximately 720 kilograms and generated thrust of 8.8 kilonewtons, but only if its turbine section could survive the thermal assault of compressed combustion gases. Germany's critical shortage of heat-resistant metals forced a devastating compromise. Chromium and nickel, essential for conventional turbine alloys, had vanished into the Reich's prioritized production channels. Junkers metallurgists turned to chromador, a high manganese steel substitute that could be manufactured despite resource constraints. The decision saved the program. It also doomed the engine. Chromador turbine blades exhibited catastrophic creep and deformation under operational stress. Service life ranged from 10 to 25 hours before failure became inevitable. 2 engines per aircraft consumed every 5 to 12 missions, meant depot-level maintenance became a constant drain on Luftwaffe logistics. The twin-engine fighter required both power plants replaced at intervals shorter than a bomber crew's tour of duty. Rapid throttle changes induced compressor stalls. Debris sensitivity demanded concrete runways. Grass fields risked foreign object ingestion that could shred compressor blades in seconds. The Messerschmitt design team had engineered a swept-wing airframe spanning 12.5 meters with length of 10.6 meters, an empty weight fluctuating between 3,800 and 4,419 kilograms depending on equipment configuration. Maximum takeoff weight reached 6,400 to 6,410 kilograms across the fighter's wing area of approximately 21.7 square meters. The all-metal horizontal stabilizer featured adjustable incidence controlled by electric motor screw jack mechanism with pitch indicator and adjusting switch positioned in the cockpit for trim adjustments during high-speed flight. March 27, 1943, brought Erhard Milch's ruling favoring the Schwalbe over Heinkel's competing He 280, citing superior range. The Messerschmitt jet flew 2/3 farther than its rival. Production authorization arrived even as the fundamental propulsion compromise remained unresolved. Autobahn strips would serve as improvised runways in the conflict's final weeks, concrete emergency taxiways transforming into launch platforms. The engineering miracle and its fatal flaw now moved toward mass production, turbine blades already counting down their brief operational lives before the first combat sortie ever launched. October 1944 brought the jet age to combat over Germany. Major Walter Nowotny's unit assembled at Akmer and Hesepe airfields, flying Me-262, A-1A fighters stripped of the bomber pylons that had hobbled earlier variants. Messerschmitt delivered 123 airframes that month from Augsburg and Regensburg facilities, feeding a growing force designed for one purpose: destroying the bomber streams that darkened German skies daily. On October 7, Nowotny's jets intercepted a B-24 formation over Rhine. Convergence points sat at 450 meters, where 4 Mk-108 30mm cannons delivered 330-gram shells at rates approaching 600 rounds per minute. 3 hits obliterated a B-17. 1 often sufficed for fighters. The muzzle velocity of 478 meters per second limited long-range accuracy, but high-speed passes brought German pilots close enough that precision became irrelevant. "Where we got in range, bam," one combat veteran recalled, describing attacks that gave bomber crews no time to react. The tactical advantage was absolute in those autumn weeks. American P-51D Mustangs topped out at 703 kilometers per hour, 167 kilometers per hour slower than the jets screaming past them. Luftwaffe pilots exploited this speed differential through diving attacks that compressed engagement windows to seconds. The 100 rounds loaded in each top-mounted Mark 108 and 80 in each bottom gun lasted just 10 seconds of sustained fire, but jet pilots needed only brief bursts. Adolf Gallen's earlier description, "as if an angel were pushing," captured the sensation of power these pilots commanded over propeller-driven opponents. Production momentum supported Nowotny's operations. September had yielded 91 Me-262s. October's 123 represented a 35% increase. November would deliver 120 more. The mathematics appeared favorable until November 8th, when Nowotny himself died returning to Akmer in a damaged aircraft. His Me-262 crashed during landing approach at approximately 200 kilometers per hour, killing Germany's 258 Victory Ace and eliminating the irreplaceable combat leadership that had made Commando Nowotny effective. By month's end, USAAF P-51 units had initiated rat-catching patrols over Akmer, Hesepe, and Lechfeld. The jets remained untouchable at altitude, but every sortie required takeoff and landing at predictable locations. American fighters began waiting at runway thresholds where Me-262s crawled through vulnerable approach speeds, transforming airfields into kill zones. Inside the Jumo 004's combustion chamber, nickel-starved turbine blades spun at temperatures approaching 1,000 degrees Celsius, their inferior alloy composition visible in the discoloration patterns creeping across hollow-forged surfaces. Germany's nickel shortage forced engineers to substitute chromador and tinidor alloys, materials that operated at the absolute threshold of metallurgical tolerance, their crystalline structure deteriorating measurably with each operational hour. Gas temperature gauges in cockpits displayed red marks at 680 degrees Celsius, warnings that turbine blade stress limits were approaching catastrophic levels. But combat throttle demands routinely pushed readings beyond safe parameters. Pilots throttling up for takeoff faced impossible mathematics. Insufficient power meant settling back onto concrete at 200 kilometers per hour with full fuel loads, while aggressive acceleration risked turbine disintegration at the moment when altitude mattered most. In May 1944, Hitler issued the directive that reconfigured the twin-engine interceptor as a blitz bomber, mandating 500-kilogram bomb loads and delaying pure fighter deployment by 6 months. Schenck's detachment received Me 262 A-2A variants with 2 underslung 250-kilogram bomb pylons and extra 132-gallon rear fuselage tanks, equipment that reduced climb performance precisely when Allied fighter sweeps intensified. Only 300 ever saw combat. The 10-year technological leap arrived without logistics, fuel reserves, or the pilot cadre to deploy it at scale. By May, remaining Me-262s sat abandoned on grass fields, some blown apart by retreating crews, roughly 200 captured intact by advancing Allied forces. The future of aviation ended as static displays. If you enjoyed this story, hit subscribe for more World War II historical deep dives every week. Thanks for watching.